from a conjugated system known as minus R or minus M groups. Known as minus R or minus M groups. Written? Now, here point is just like plus I minus I. Some order we are going to write, which is useful for other chapters. Plus M plus R group means they are electron releasing groups. And which electrons they are releasing? Pi electron density. Pi electrons are involved. So which example you can say CH2 minus strong, NH minus, all are negatively charged, lone pairs are available, O minus. Then you can write neutral example NH2, Nr2, OH, OR, NHCOR, amide, OCOR, then halogens, ठीक है. So these all contains lone pairs or negative charge. That is a key point. That which atom, which group can be plus M, you can say directly which contains lone pair or minus charge and directly bonded to a conjugate system. But which is stronger, which is weaker, that you have to learn properly from the order here. Because sometimes one or two examples randomly they are compared. Not all examples together, all orders cannot be remembered. Remember means you have to learn it properly, but all together cannot be used. They can be used one or two, 1, 2, 3 possible. Yes, Pramoda, you have to learn it just like plus I, plus M, minus M. ठीक है भाई? So that is the order now. Among them, if you observe here, these were also present in inductive and they are which groups? They are plus I. So they are both. No need to require any principle, avoid any reasoning part because reasoning work for few examples. Then you will be messed up with the orders. So best way is whichever frequently used that you will remember. And in the questions directly apply like O minus, NH2, alcohol, OH group, halogens frequently used. Because reasoning part not from the mesomeric effect, they are arised from different reactions, comparison of rate of reactions, from that it is compared, written. Okay? So these first three, they are both effects. Both means both electron releasing effects, plus M as well as plus I. But after O minus, NH22OCOR, it means ester, they are plus M and they show which inductive effect? Tell, they show plus I or minus I from NH2 to OCOR. Which inductive effect they will show? Very good, tell. Yes, they are all minus I groups. If you revise minus I, N withdrawing group, O withdrawing group, very good. So they are minus I. Now for these groups, you have to learn that generally their electron releasing effect dominates as compared to their electron withdrawing effect. So that is pure observation from the reactions. So you can say plus M greater than minus I, or you can say plus R greater than minus I. ठीक है. Written. Now halogens very important. They are both plus M and minus I, and their which effect dominates? Withdrawing effect dominates. So minus I or electron withdrawing effect is more dominating as compared to their electron releasing effect. In CS2 minus, no need to consider. Why? Both are same nature. Both are electron releasing, no use of any comparison. Comparison is where required, where both are opposite. So we have to remember certain information. Halogens dominating part is their withdrawing nature. Some examples will be explained by plus M effect also. So those examples I will tell in the respective chapters. ठीक है? So this order you have to learn. Then other is minus M or minus R order. Minus M or minus R order. Minus M or minus R order. So among them, the most relevant is NO2, cyanides, most commonly used. Then you can say aldehyde, ketones, ester, carboxylic, amide. Whichever are C double bond O, they all are withdrawing groups, but we have to remember this. Which is stronger, which is lesser. Among them, all are minus M, all are minus I. So no need to think about which dominates, because all are electron withdrawing in nature. Most commonly used NO2, cyanide, aldehyde will be used in particular chapter. Remaining less used directly for minus I, but yes, they have minus I effect. CH3 is alkyl group. It is never showing any plus M minus M. It shows plus I and hyperconjugation. That hyperconjugation will be after resonance. Up to this point written, this order you have to learn properly. Yeah, Srikara, they all are minus I also, because all are with C double bond O or nitrogen, all are withdrawing in nature. Electronegativity high. Now applying this concept of plus M and minus M. First example, phenol. There is no any dominance required when both are same nature. When we use dominance part, when both are opposite in nature, then we have to consider finally which is dominating. Getting it? So here all are minus M, all are minus I. But that means both withdrawing natures. So now use this concept, it's a conjugate system. OH has its effect because it's a group where lone pairs are present. So its effect will be observed by delocalization of electrons in the ring structure. So write down the resulting structures of phenol and OH. Just now we have done it is a plus M group, lone pair containing all are plus M groups. Plus here, minus there. Try to write other resonating structures also. Then I will write, then you will check. Written. Resonance delocalization is done. Syam has given the answer. Very good. Other students also. Write down all resonating structures of phenol. Negative charge always move away from the atom. Above as it is OH plus, minus charge here. Then minus charge delocalize further. How many resonating structures are there? Syam has given answer. Other students, how many resonating structures? Is it 3, 4, 5, 1? How many resonating structures of phenol? Syam has given, Amrut has given the answer. Very good. Rakshita has given answer. Raymond given. Harita given. Okay. Haripriya. Palmini given answer. Answer is 5 resonating structures. Very good. Those who are getting 5, they are correct. Other students, they might be considering first and fifth are same, but you forgot one thing. In first and fifth, position of sigma bonds or atoms same, but position of pi bond is different. So there are how many resonating structures of phenol? 5 resonating structures. Try to write for another important example is NH2 on benzene. No use of any formula because resonating structures writing is useful in the reactions. You can observe one thing that in the first example plus M group was present and its effect on the benzene is negative charge is there on ortho and para position. It means plus M group increases the electron density at which positions? Ortho and para. Meta is not affected by the plus M effect of OH. ठीक है? Phenol example written. Phenol example is completed. Very good. Write down the other structure of aniline NH2. These are the resonating structures of aniline? Answer is 5 structures. Very good. Yes, correct it is. Return. So you can mention this point after this example, that you can mention plus M groups. Plus M groups increase electron density. Plus M group increase electron density at ortho and para positions. Increase electron density at ortho and para positions. Written. Srinidhi Rao, that point we will cover in hydrocarbon directing effect later on. Now next example is from minus M. Now minus M group में you can observe in minus M group, what is the point? Withdrawing group is this. That means pi electron density will be withdrawing towards more electronegative atom. Which note saying Rami Sethi or saying once again? Okay, what point I said? I said in the previous example, plus M group increase the electron density at ortho and para positions. ठीक है, रवि शेट्टी, ललिता प्रीति. Written. Now next example is benzaldehyde CHO. CHO we have done which group? Minus M. So it will withdraw the density from the benzene ring. How? It can be shown by arrows like this. Pi electron between CO is shifted towards more electronegative atom, towards oxygen, and carbon become deficient. Benzene will give the electrons. So this becomes here double bond carbon, here oxygen minus, here hydrogen, and here it is plus charge. Now this plus will be stabilized by delocalization in the benzene ring. Here double bond, here it will be positive. Other remains same, CHO minus. Yes, correct, it is Syam. Then another structure, delocalization of positive charge, pi electron shifted towards carbocation, and here it is plus, and then it's plus with CH, here it is O minus. Then next structure, same, delocalization is taking place, and again benzene is retained with CHO. ठीक है, और ये बन गया डबल बॉन्ड, सिंगल बॉन्ड, डबल बॉन्ड. So by these structures, you can easily observe the positive charge is delocalized on benzene. Positive charge means electron density is reduced. That is why you have written these are electron withdrawing groups. These are which groups? Electron withdrawing groups. How it is proven? You can see that benzene getting positive charge. Positive charge means deficiency is created. And where which positions are more deficient? Ortho and para positions. Which positions are electron deficient? Ortho and para positions. ठीक है, तो you can write one point. Minus M groups decrease electron density. Minus M group decrease electron density at ortho and para position.